Now we have discussed state postulate, etc., system, etc. Now we are moving to equilibrium of a system. So equilibrium, we know that it is a balance. It's a state of balance. So what do you mean that in thermodynamics? So the word equilibrium implies a state of balance. So in an equilibrium state, what happens? There are no unbalanced potential. Okay, driving forces within the system. It can be temperature. Of course, one part of the body is high temperature, other part has low temperature. That means heat will flow. So there is a lack of equilibrium. That means there is a driving potential. Temperature is not uniform throughout. Also, that can happen if one area the pressure is high and low, other area pressure is low. Then obviously there is a flow from high pressure to low pressure. There is an unbalanced potential. Okay, so if you don't have any unbalanced potential, then it is called an equilibrium. So there are no driving forces within the system. So a system in equilibrium means it doesn't experience any change, okay, when it is isolated from its surroundings. The system surround uh, if it is isolated from there is no interaction between the surroundings, that system will remain same. Its properties, there will not be any change in properties. That means the state of the system will not change. So let us see what are the types of equilibrium in thermodynamics. Types of equilibrium means thermal equilibrium, as the name implies. It means there is no unbalanced temperature throughout the system. Temperature is uniform throughout. Then you have the mechanical equilibrium. That means the pressure. That means pressure is constant throughout the system. Then you have the chemical equilibrium, that there is no unbalanced chemical potential throughout. Okay, then you have the phase equilibrium. Phase means from liquid to vapor, vapor to liquid. This is the phase. That means if there is any unbalance in that, there will be more vapor will be produced. Otherwise, more condensation occurs, more liquid will be produced. So this is what you mean by these are the different types of equilibrium. Let us see each one of them in detail. So let us see what is thermal equilibrium. Okay. In thermal equilibrium, you can see that here. Uh, See, before you can see that what happens. So there is a gas inside this container. So temperature is 20 degrees Celsius, 23, 30, 35, 40, 42, etc. After some time you can see that temperature is uniform. Now it has reached equilibrium, 32 degrees Celsius throughout. So you can see that system is in equilibrium. Earlier here the system was not in equilibrium because there was unbalanced temperature difference throughout. So after some time temperature will be uniform and you can see that the system is in thermal equilibrium. So here you can see the system involves no temperature differential, which is the driving force for heat flow. That means temperature is same throughout the system. So that is the important condition for thermal equilibrium. And let us see what is phase equilibrium. So here, see, in this case, first order it was open, so the water will evaporate continuously and this will go out. That means there is a phase equilibrium. It will, because this flows to atmosphere and again it evaporates and it moves out. Okay, so that is a phase, is not in phase equilibrium. Now if it is closed, you can see that if it is, let us say it is closed, so some of the molecules will get evaporated and moves to the this area, and some of the water vapor molecules will condense and go back to this, right? Once the phase equilibrium reaches, the number of molecules evaporating will be equal to the number of molecules condensing. So that is the difference. Okay, now here this is in phase equilibrium. So phase equilibrium is when mass of each phase reaches an equilibrium level and stays. So here you can see in the second case, the mass of each, though there is a some of the water vapor may condense, an equal number of water will evaporate. Okay, so the mass of each phase reaches an equilibrium level and it will remain same. This is called phase equilibrium. Let us see what is mechanical equilibrium. You can see the state A and state B. See, in state B, you can see that throughout you have the same pressure. Okay, so what happens is that when this piston is moved suddenly, the air molecules here will be compressed much more than the air molecules here. Okay, in that case, you can see that here the pressure will be higher. Okay, and here the pressure will be lower. That means there is an unbalanced potential. That means it is not in equilibrium. So once it is still, so you can see that wherever you take, you have the same pressure near to this piston also. If you are moving very slowly also, if the piston is moved very slowly, then you have the same pressure throughout. So a system is in mechanical equilibrium if there is no change in pressure at any point of the system with the time. So you can see that after some time also the pressure is not changing, right? So that is when you say it is in mechanical equilibrium. Now what is chemical equilibrium? So you can see that see initially there was two components A and two gases A and B. So these will react together and will form gases C and D. Okay, so because once the reaction is complete, there is no further reaction. So you can see that this is in thermal equilibrium. Initially this was not in thermal equilibrium because there was a reaction, there is an unbalanced chemical potential. So reaction occurs, finally it will stop from components C and D. So the chemical composition of a system does not change with the time, so there is no chemical reactions occur. So once we have understood what is equilibrium, so a system is in equilibrium only when all these are in equilibrium. That means it means you should have thermal equilibrium, phase equilibrium, mechanical equilibrium and chemical equilibrium. All these are satisfied only then you can say that a system is in equilibrium.